Thanks, Michael, and thanks everybody for coming out. I know it was definitely an epic party last night. I had a lot of fun too. I might not have actually shown up today, so I really appreciate that. So before we kind of kick this off, a lot of people kind of want to know, like, so who is this guy? I haven't really heard of him before. What does he get the keynote? So I am the chief architect at Perforce, but I mostly focus on our open source strategies within Perforce. And I do a lot of this type of work, right? So it's a lot of training, it's a lot of speaking at events. I'm really more of an evangelist than an architect, I think. But I am very privileged to work with what I really think is one of the greatest open source strategy teams in the world, and that is our Open Logic team within Perforce. So I consider myself a curator of free software experts. I've been a programmer, an architect, a blogger, a speaker, a trainer. I still do a lot of those things. And I am an obnoxiously evangelical supporter of free and open source software. I have fully drank the Kool-Aid. I believe this is the best engine for innovation that the world knows right now. And so we're going to talk about that for a little while. But to begin with, I've been at this for a little while. That's me probably 6 or 7 years old in front of my first computer, which was a Tandy Radio Shack model 1000EX. Which might date me just a little bit. My dad bought this computer. He worked in advertising, and I guess a lot of his friends were getting computers at that time, and he thought it would be a good idea to, use one. He never learned how to use it. He still barely knows how to use his phone, but I hijacked this thing immediately and fell in love with it. And for those who are familiar with the Tandy Radio Shack lines, to really do anything effective with these computers, you had to learn a little bit of programming. For me, that was copying line by line, rote repetition of stuff out of the back of a Micro Center catalog into my GW Basic interpreter, and that might be familiar to some of you, but this would basically end up taking over my entire childhood, which I know I'm not alone in that statement. I think a lot of us have probably been there. I was kind of the neighborhood computer guy growing up. I was like that little 9-year-old that they'd send over to fix a printer or whatever. I did start a computer club in my high school because that's what a cool guy I was. And I started a prolific bulletin board system actually in Atlanta, which was a lot of fun. And a lot of people were kind of surprised to hear that it was a 12-year-old running that at the time. But there was one big problem. And that was that this was still the 90s. All right, most people couldn't even spell HTML, let alone my parents or the people that I knew in my community. And so I would ask them for something like upgraded storage or a higher baud modem or some type of compiler. They would kind of look at me like this, like, what are you talking about, kid? So asking for that kind of thing, like an expensive compiler, was a lot like asking for a pet unicorn. It may as well have just been the same thing. They really had no idea what I was talking about. And so it was difficult to get my hands on real compute resources until something happened in the mid-90s. I was saved by these two folks here. And this really was kind of a magical time. Among others in the free software space, it was really these two that would trigger in me, I guess, a chain of events that would lead me through my career. It would take me here today, on the stage, talking to all of you. This is, of course, Linus Torvald on the left, the apotheosized creator of the Linux operating system. On the right, we have Larry Wall, who's the inventor of the Perl programming language. And so suddenly, for free, I had access to all of these resources that I needed to be able to continue to learn and do more with these things that I was so fascinated with. So really, if it wasn't for this, if it wasn't for the introduction of free software, I don't know that I would have had these types of resources available to me. So these became some of my best friends, and today we're going to talk about a subject that is very near and dear to me, and it's one that I would happily and have waxed poetic for hours and hours and hours about. Luckily for all of you, they only gave me 45 minutes to talk, so I will try to hit some of the high notes here. So we're going to talk about free software, and I don't mean free like you don't have to pay for it. All right? I think we all already understand that part of it. And to me, that's the least interesting part, okay? The most interesting part is the freedom that this software gives us. We can pull it from public repositories. We can study its source code. We can modify that source. We can contribute back to it. We can use this software in ways that might not have been originally intended by the authors. And that's amazing, right? We can't do that with proprietary software. So because of that, when we're dealing with openness, we're able to accelerate in a direction that's just harder to do when we're attempting to do this type of work with a more closed methodology. This openness and this freedom is the key to human innovation. I truly believe that. I don't think that there's a force in the world today that's accelerating human innovation at the pace that open and free development is right now. And if we look at some of the examples of this, OpenAI from Facebook, right? This is one of the premier artificial intelligence and machine learning platforms that it's out there, and it's completely free and open source. For anybody who's interested in learning about neural networks or machine learning, it's there for you. You could use it and consume it right now. The open source malaria initiative. This is one actually using open medical principles and biological science principles and software to try to combat malaria in a new way. Hyperloop design, of course, this is Elon Musk's and Tesla's invention. It's not going too super well right now, but we'll see what happens. And then, of course, LibrePlanet, which is really a consortium of developers and thinkers who are using open principles to try to solve some of the biggest problems of the world. And I think it is these principles that are going to solve some of the biggest problems of the world. I think it's going to cure numerous diseases. It's already bringing us autonomous vehicles. It's going to fundamentally change the way that our society works again. Gartner recently predicted that over the next 10 years, based on what they're seeing in terms of acceleration of hardware in the data center and the way that we're achieving new milestones in things like AI and machine learning, we should expect to see 10 times as much change over the next decade than we saw in the last. Take a minute to absorb that, because a lot's changed in the last 10 years. Now multiply that by a factor of 10, and that may very well be what we're looking at here. You might even be able to put your brain inside of a robot body, if that's what you're into. And it's probably going to bring us something similar to the holodeck. So why don't we start talking about that? Maybe we'll begin then with some dramatic exposition. So the year is 2250 in our story, and the United Federation of Planets has sent an RFP. And the goal is to build a device that's fully capable of simulating experiences for the purpose of education, tactical analysis, and of course, recreation. So dozens of civilizations begin research on this. We're going to follow two of these researchers through this story. The first is Ida Hopper. She is a Federation computer scientist and the leader of a distributed software community of developers. She's a maintainer. She's going to leverage her community to prototype this and develop a proposal, an RFP. On the other side, we have Kolas, who is a Klingon computer scientist, and he's forced to work in secret. Science is not highly regarded by Klingons, nor is working on a Federation initiative. So hopefully it's clear what we've set up right now. Ida's looking at open and free development principles to complete her work. Kolas is forced to work in secret. And so research begins. Ida Hopper draws her inspiration from the philosophies of the Free Software Foundation. And I need to take this opportunity to get real for a minute. A week ago, this presentation had several slides on Richard Stallman. For those of you who are familiar with him, he was the former president of the Free Software Foundation at MIT. He was someone who I held in very high regard. A lot of us did. If you're not aware of the comments that he made last week, I would encourage you to go look on your own. I don't really want to focus on it, but I can no longer put any endorsement behind this man. So if it looks as if Richard Stallman is suspiciously missing from this presentation, he is. I found his actions to be unconscionable as a father to daughters, as a husband to wife, as a son to mothers. I just can't throw any endorsement behind him. But I do want to think of it as an opportunity for new leadership and new ideas within the Free Software Foundation. They're looking for a new president, right? And hopefully it's going to be somebody a little bit less toxic, a little bit more progressive, and somebody who I think can maintain relevance socially with the work that we're doing here. And that's all I'm going to say about that. So the Free Software Foundation was quite prolific in the late 20th century, okay? And they were founded in 1983. So for those who are familiar with the open source initiative, it's about 13 years before the formation of the open source initiative. So I want you to make sure that we really understand what we're going to talk about here is that there is a difference between free software and open source software. And this quote kind of sums it up, where we say that free software is a matter of liberty, not price. To understand this concept, you should think of free as in free speech, not as in free beer, okay? Again, we really want to underscore here that the interesting part of free software is the freedoms that it gives you. And there are fundamental differences then between free software and open source software. Now, most free software is also open source software, but it's not necessarily true the other way around, and it really comes down to the way that that software's freedom is protected by its license. And that is a big part of the goal of the Free Software Foundation. They wanted to ensure that software exists which is free to implement, study, and modify in any way that suits the user. In other words, the user gets to control the software. I mean, imagine that. I don't think we really think about it too much these days. But with so many restrictions that are placed on our devices, things like DRM and copyright mechanisms installed on our software, we're not telling the software what to do. The software's telling us what to do, okay? But with this type of software, where we're truly free to do whatever we want with that source code, we're back in control. So when we call software free, we mean that it respects the user's essential freedoms, the freedom to run it, study and change it, and to redistribute copies of it without changes, all right? So what do we really see here? We see a difference in philosophy, okay? In about '98, part of the free software community and started campaigning in the name of open source. And this term open source became associated with these ideas or arguments that were based on practical values. Okay, now I'm not saying this is bad, right? I'm just saying it's different. The goal of open source was to create a new methodology for creating great software, okay? But the goal of the Free Software Foundation was to make the world a better place, all right? So whereas open source has been considered a new way of developing software, free software really is more of a social movement. And it's protected by this license called the GPL, which is, of course, splintered. There's other versions of the GPL, but we're going to talk about mostly the principles in GPL v3. This license was created by the Free Software Foundation, and it carries the purpose of making sure, almost militantly, that any freedoms that are enjoyed by somebody who's consuming or using GPL-protected software must extend those freedoms to other users. And so it becomes a soldier of innovation, as I like to call it. What does that really mean practically? It means that if I consume a piece of GPL software and I modify it or change it or try to improve it, I am obligated by the terms of that license to push those improvements back into the community, all right? I am not allowed to fork that code. I'm not allowed to assume ownership over it. This is what we would call a non-permissive license. And if you ask me, that's the only type of license that actually protects software freedom. Let me give you another example. We can take a look at the MIT license or the ASF 2.0 license. These are considered permissive licenses. Anybody who wants to could take, say, the Apache web server, which is protected under Apache 2.0, throw it on some piece of physical hardware, stick DRM in front of it, and suddenly it's a felony for you to even poke at that part of the hardware because it's protected by DRM. That's not free. The software is no longer free. The GPL ensures that you're not able to do this, okay? And now I understand the flip side too. I mean, again, I'm a purist when it comes to free software. I know why businesses are afraid to give back or potentially risk sharing their intellectual property if they modify code that's in the GPL, but study after study and paper after paper has really suggested that the benefits of being involved, the business being involved with a free software initiative, the academic benefits and the educational benefits far outweigh the risk of any loss of IP or anything like that. So freedom at all costs. Permissive licenses, as we said, can be sort of problematic because nothing forces developers to give back what they've modified. Or worse, that software could be deployed in a closed way. There's just too much room here for ownership, which is not, I mean, it might be good for a company, but it's not good for human innovation as a whole. So Cory Doctorow, another of my heroes actually, described the GPL as a Ulysses Pact. This was in the 25th anniversary Linux Gala. I actually had the privilege to hear this talk. It was one of the best talks I think I've ever heard. And I did email Cory and ask him if I could steal his idea for this talk, and he said it was fine. It was a talk called Lock It Open, and it talked about how free software helps us become our better selves. And I really found this metaphor to be pretty apt. So what is Ulysses Pact? All right, well, so if we're familiar with the stories with Ulysses, we know that Ulysses was sailing through the island of the Sirens. He wanted to hear this infamous siren song, but he knew that there was a possibility that could drive him crazy, kills his whole crew, and then jumps into the water, right? That's what happens in the story. So what does he do? He tells his crew to time to the mast, right? He makes his crew stick wax in their ears so they can't hear the song. And he has them, draw all the swords on him and everything, that if he breaks through the mast, he's very clear. Go ahead and kill me before I kill you. All right? This is a Ulysses pact. What is it saying? It's saying, it's not that I don't trust myself to make the right decision in the future, but I know I could have a moment of weakness, and I might need to protect myself from that. All right? The GPL says, if I go and push code out, and I publish it under GPL, for altruistic purposes, for the purpose of helping a developer community, and then a couple years later, somebody figures out that they can make $1 million off of that, I'm not allowed to call backsies. I can't say, oh, whoop, no, sorry, that was supposed to be closed. Nope, I'm not allowed. The GPL doesn't allow me to do that anymore. So it's a Ulysses pact. I am guarding myself against potential future greed that would be bad for innovation as a whole. And these pacts are pretty important. I made one about 3 years ago. Don't keep cheese around. Look a little different now. So these packs can be helpful. But listen, it's all good, okay? Free is different than open. Just about all free software is also open software. The goals may be different. The impact is the same. By fostering and encouraging free and or open development, we create shared communities, many of which I'm sure you're already involved in. By keeping that creativity and innovation open, we increase the collective creativity of the world around us, and by doing so, we accelerate human innovation. So let's kind of see some of this in action. How does free software sort of build on itself? Well, if we look at a timeline of open development, which I realize I could probably use another block there at this point, but we look at some of these pieces of software and we look at how they've evolved. So we start with the Emacs editor. That was actually the first piece of free software ever specifically licensed as free software back in 1976, okay? A little bit of a while ago. We saw the Free Software Foundation come a few years after that. We saw the GCC toolchain, which allows us to compile C++ applications and C applications in a way that's free. And we saw the rise of the language Perl. Well, Perl was written in C, and Perl is also a free language. And people would start using Perl on this Linux thing that popped up in the early 90s. For anybody who's familiar with that story, it's a great one. Linus Torvalds posts a message to the list saying, oh, I got this little hobby thing. It's not going to be big like Minix. It's just I'm just kind of playing with it. We'll see what happens. That, of course, was Linux. And we know what happened after that. But with Perl and Linux together, we started saying, well, now we're writing web applications using a weird scripting language. Why don't we write a language that's specific for web applications and make it open source? And so we ended up with PHP. Well, now we need a better way to host these web applications. And so you saw the rise of the Apache web server, which is another great story. Anybody familiar with Netscape web server, previous to Apache web server, might know that that was about 1,800 lines of code that was being sold for exorbitant amounts of money to companies. It's a very simple application. And that all came tumbling down with the introduction of the Apache web server. All right, so let's do a static check. Let's see how our researchers are doing. So Ida's ready to get some servers kickstarted, and her assistant here has initiated a script that's going to pull CentOS version 220 from our public software repository and all the utilities that we need from community sources. So what are we doing? We are seeding our environment that we're going to be doing our work in, but we're pulling everything from public repositories. So when will it finish? Probably about 5 minutes ago. We're able to script all of that. It's very easy. So let's get to work, and Ida's going to create a GitHub. Meanwhile, poor Colas needs data on the discovery of Zerillion holographic chambers, but that information is classified. He's got to go through the proper paperwork to get it. He also needs servers and operating system to do his work. So great, his assistant's going to get with procurement. Just give him a few weeks, and maybe your environment will be ready. So we're already way behind. Ida's already finished with the provisioning phase on day one, whereas Colas now has to wait for procurement to get licenses and install operating systems and do things from proprietary media and all that data that he wanted released. So Colas is really dealing with some of the problems of a closed development environment. And this really isn't anything new. these problems in working in secret and not collaborating and not sharing information have caused historically a lot of problems. One story that I really like is this idea of alchemy, right? So if anybody's looked into alchemy, there were some discoveries made. I mean, it wasn't great science, but there were some contributions that were made. The problem is that all these contributions, all this work was done in secret. So you ended up with these alchemists like individually creating these elixirs of life made out of like arsenic and mercury and like drinking them and dying. And if one person had just been able to like share, hey, you probably shouldn't drink arsenic, then a lot of alchemists may not have died. Another one that I like to talk about is this guy right here, Pythagoras. A lot of you may recognize Pythagoras from geometry, or at least you probably remember this equation, a squared plus b squared equals c squared. This is the Pythagorean theorem, of course, that allows us to calculate the hypotenuse of a right triangle. Pythagoras, the way that people looked at knowledge when Pythagoras was coming up is a lot different than people look at knowledge now. You probably heard it called esoteric knowledge or sacred geometry or any of these things, and they have kind of like this, weird conspiracy stuff associated with it, most of which is completely untrue. What it really was that back then, mathematical discoveries looked like magic to the average populace, right? They didn't understand that through technology and engineering, we were able to do things like create amazing buildings that we couldn't create before. So this type of knowledge that Pythagoras had was considered divine knowledge. All right? And Pythagoras believed that too. He thought that mathematics was the language of nature. He thought that all objects actually expressed themselves mathematically through music. Music factored into a lot of his teachings. So he's a very interesting guy. And so he forms this school. And the school is comprised actually of two separate groups in the Pythagorean school. We have the acousmatics, or the listeners, and we have the mathematikoi, which is really more like the learners or the inner circle. The acousmatics really acted more like servants, I should say, to the school, right? They just they were like interns, right? But they didn't really get to learn any of this divine knowledge that Pythagoras was reserving for his mathematikoi, or his inner circle. And there were a few problems with this. One of them was that we really actually don't know all the discoveries that we could now historically attribute to Pythagoras, because there weren't really good records kept. It's hard to know if there were other good mathematicians that were making advancements at the time that he was collaborating with internally, because all this work was done in secret. But there was an even more immediate problem, and that was a guy named Cylon. Not that Cylon, the real Cylon, who was a nobleman and a leading citizen of the city of Crotone, where Pythagoras had his school. This is in modern-day southern Italy now. By account, Cylon wanted very much to be accepted into Pythagoras' inner circle. And being a nobleman, he considered it his birthright. And we're going to revisit this concept of birthright in a moment, too, because this is a really major theme that was overturned during the Age of Enlightenment, which is part of what this talk is about. So he just thought he belonged in the mathematikoi because he was born of noble birth. But Pythagoras did repeatedly refuse his requests, and ultimately that would lead to Cylon revolting against the Pythagorean school in about 509 BC, killing a bunch of people, and Pythagoras ended up dying in exile. All because of this secrecy, all because of this knowledge that there were these discoveries being made, but they were reserved. They were held for a specific group, and it pissed people off. But thankfully, human civilization did find a light in the middle of sort of all of this superstitious and secret periods. And they discovered this during what's one of the most important periods of human innovation, what we would call the Age of Enlightenment. Really wasn't until Enlightenment that we pulled ourselves out of these sort of widespread, secretive schools of thought and instead developed open learning communities. This was a major theme of Enlightenment. The guiding principles of Enlightenment are often summed up in this quote by Immanuel Kant. Dare to know, have courage to use your own reason. This seems like a no-brainer now, but you have to remember that this was a time where most people were illiterate. There was a lot of snake oily stuff and a lot of things like nobility, pushing facts that were clearly not facts, but because might makes right, we're kind of stuck in this position. And Immanuel Kant breaks all this down and says, no, dare to know, Have courage to use your own reason. Don't follow the ideas of somebody else just because they're in power. Think for yourself. And most historians then actually place the beginning of the Age of Enlightenment around 1620 with the publication of Sir Francis Bacon's Novum Organum. This would shatter fundamental approaches to the way that we thought about approaching problems of society, problems of politics, problems of philosophy, because it would involve a philosophy called reductionism. Reductionism says in order to solve a problem, we need to look at its component parts, its individual parts, as opposed to looking at the whole. And that individual is absolutely a key word here. So this philosophy challenged then the more monolithic ideals and sort of gave rise to ideas like individualism, which would ultimately lead to things like the establishment of the scientific method. So the guiding principles of enlightenment should sound pretty familiar to the way that we kind of do things now. The sharing of ideas through publication, the rise of the public sphere, the public domain for knowledge, individual liberty, creative freedom, and sure, the scientific method and reductionism. One of the most important publications of the time was contributed by Isaac Newton. He was, of course, a renowned 17th century astrophysicist and astronomer and mathematician. And he published a book called Principia Mathematica, arguably the first mathematical engineering knowledge manuscript ever publicly published. If you've heard the term in open source, standing on the shoulders of giants, this is one of the first examples of that. You have this person who is a genius sharing his ideas about math and physics with the world at large so that other people can learn from it and build on those theories. Right? That had never happened before. People kept this knowledge to themselves out of a sense of propriety. So it does present early evidence, though, that this culture of collaborative learning leads us to faster innovation, because it was absolutely the publication of this book that then led to incredible advancements in the field of engineering and philosophy over the time. We had another publisher at the time, too, a guy named John Locke. Not that one, though, this one. And he published a book, a really revolutionary work of philosophy, actually, called Essay Concerning Human Understanding. This essay is what ultimately would tear down the nobility, okay? Whereas birthright, and the concept of birthright, says that you are born with certain divine advantages, or that you deserve certain things because of the blood that runs in your veins. This turns that around completely and says that, as John Locke called it, every human being is a tabula rasa at birth, or a blank slate. We're all born with the same basic incapabilities. And then through our own experience and knowledge and interaction with other people, we become who we are, right? This is a much more individualist notion than the idea of something like nobility and birthright. And we really see this sort of leading the way towards things like individual freedom and meritocracy, and philosophies that have ultimately pushed us towards more openness. We saw the rise of the Florentine bodega at the same time. These are open communities at work, buildings where painters and sculptors and poets and writers would all work together and collaborate on ideas and the free share of information. This would give rise to people like Leonardo da Vinci. To me, it actually reminds me of GitHub. Or Parisian salons, right? Another thing happening during the Age of Enlightenment, where people of all walks of life and classes would get together and discuss the times of the day. And again, just you see this explosion of free thought and the sharing of ideas. So let's check back on our progress here. So IDA's using TensorFlow version 240 to automate all the artificial intelligence subroutines that are necessary. Didn't TensorFlow almost destroy humankind in the year 2125? We don't talk about the Google wars around here anymore. So we'll carry on. And how about poor Kolos? Well, good news from his partner. They got the servers commissioned, and in a record 3 weeks. When can he use them? Well, we have to get access to the Sandbox network, so we need a saliva sample from Kolos so that we can link it to our DRM identity servers. So that's just going to take a few more days. I think we see where this is going. So IDA's already in her development phase, proof of concept, has already been able to build the entire substrate or infrastructure in which all of this compute is going to happen, as well as begin to pick technologies to build the proof of concept. Poor Kolos is still waiting for access to his servers. So what are these problems with closed development that I keep talking about? What are they materially? Well, we all probably run into something like this before in the past in our own career. So difficulty or slowness obtaining software or media, just access to the software, all right? If it's proprietary, you gotta get it from behind a login wall, or it's on some kind of proprietary media. You can't just go grab it through your package manager and get it up and running, all right? So just like simple access to the software is a lot harder when you're developing against a closed model. Inflexibility in growth and scaling. If I want to increase the size of my infrastructure, it probably means I have to pay more of a license cost, right? So now I got to go and call somebody anytime I want to grow my infrastructure a little bit. I don't have the ability to modify feature sets. I'm stuck with what I get from the company. And I don't have an ability to learn or improve upon the works of others. And there's less oversight by additional parties, which absolutely leads us to less security on the whole, provably. There's also areas where, innovation would absolutely stagnate if we didn't have openness. So some of you may recognize this as a diagram of the first part of a TCP handshake. Can any of you imagine what the world might look like today if the TCP protocol was closed? Or if internet providers were forced to build their own proprietary communication protocols that were somehow supposed to be compatible with other ISPs? The internet that we know today simply would not exist. All right? Thankfully, TCP is an open specification. There's really bad stuff, too, that can come out of a lot of this secrecy. Real nightmare scenarios like the radioactive iodine experiments, for instance, in the US. Iodine-131 is a highly radioactive substance that's linked to excess cases of thyroid cancer. And in 1949, secret experiments took place at the Green Run site at Hanford State. This is where the Atomic Energy Commission contaminated a 2,000 square kilometer area with iodine-131 just to see what that natural exposure would do to the residents. Gave a lot of them thyroid cancer. We then had radioactive iodine experiments happening secretly at the University of Iowa. We had Harper Hospital in Detroit where babies were exposed to this stuff. And then they went and did Hanford again. They did the Green Run again a second time in 1962. Fallout research, up to 212,000 excess cases of thyroid cancer. The Holmesburg program, injection of dioxin into inmates of the Holmesburg prison, the MK Ultra experiments, exposure of over 7,000 US military personnel to hallucinogenic substances without their knowledge or consent. This led to suicides, mental illness. There was real fallout from this. Systematic experiments to erase and reprogram human minds. Okay, maybe secrecy is not the best thing. What about our current controversy over DRM? Section 1201 of the DMCA, which is the Digital Millennium Copyright Act in the US, there are other similar bills in other countries, but this makes it a felony to break DRM. This makes it a felony to break digital rights management software. There are some non-specific exemptions for this, for security workers, but the Electronic Freedom Foundation would argue that these are not specific enough, and these exemptions really should be expanded. A really good example of this one was a guy named Matt Brown, who was a security researcher at Johns Hopkins University. Matt Green. Matt Green and his team of researchers actually uncovered a series of vulnerabilities inside of Toyota and Ford and Nissan automobiles inside of the entertainment systems. And when they brought their research to these car companies, instead of saying, oh, hey, thanks for finding that stuff, well, boy, that really could have caused some problems. No, instead they threatened to throw him in jail as a felon for breaking their digital rights management software, which was technically a felony under the DMCA, right? That's the wrong attitude, okay? I do not want one company controlling the security of our new digital landscape, all right? So, how's that holodeck coming? IDA's thinking that AR Toolkit 244 is very powerful. And their GitHub community was able to leverage those components to make all the augmented and mixed reality layers that we could start projecting the holograms with. Oh gosh, her assistant, though, is saying that the director thinks there might actually be quite a bit of money in this research, and maybe we should close the source. Luckily, IDA's already released all this under the GPL. So no buts, it's too late, GPL. All right, so good work, IDA, we're almost there. Poor Colas, I really feel bad for him. He's finally got access to his sandbox environment. Now he needs to install ClingTech's proprietary AI frameworks. So a few more weeks on that with procurement, and he's just giving up at this point, and who could blame him? So IDA's way ahead. So there ain't no such thing as a free lunch, though, despite the fact that these are free components. A lot of work goes into these components. Again, going back to that standing on the shoulders of giants idea, right? We're building on the work of others. So what are some of the technologies specifically that IDA was using for this initiative? Well, we mentioned TensorFlow, originally developed by researchers at the Google Brain team. Anybody played with TensorFlow? It's really, really cool, right? I mean, what used to take like hundreds of lines of code to try to get all of our neurals in place and to do our cost optimization and all that kind of stuff, you can do it in like 30 lines of code now. It's crazy. You can also rent space on Google's TPU cloud, which is where their tensor processing units live. You can actually get a certain amount of it for free if you, for research purposes, if you want to mess around with some of the neurals that you built. Currently, this project has 875 committers and almost 2.5 million lines of code. Probably the leading machine learning framework right now. We do have other interesting ones like PyBrain and PyTorch and things like that, but I think TensorFlow is pretty much leading the way. The AR Toolkit platform that we talked about. This is a full tool chain for augmented reality applications with support already across multiple platforms. Very widespread community and developer base. This is the most widely used AR tracking platform. You're going to find elements of this library in just about any of the AR solutions that are out there, including your Project Tango and including like the Microsoft HoloLens. OpenGL, I think any gamers are probably familiar with this one, been around for a long time. Graphics library introduced in '92, and it's the standard for 3D games and apps. Continued innovation driving both software and hardware here. And why limit all this openness just to software? We have the Open Source Hardware Association. And this association, still around in 2250, is where all the ideas for the HoloLenses and mixed reality projectors and quantum assemblers and all those things that we would need to get the holodeck working came from. So we'll fast forward a little bit, getting near the end of the talk here. Anyway, IDA and her community of developers delivered a successful proposal. Colas expatriated and joined the Federation as an open source developer. And of course, by expatriated, I mean escaped certain death because he didn't get his proposal in on time. In fairness, though, it really wasn't his fault. We can see how fast we can bring things to life by leveraging free and open technologies, and sometimes how slow it is if we're trying to develop something in secret or using highly closed technologies. So in the end, I'll just say be open. The biggest problems of our future are going to be solved by open communities. They're already being solved by open communities. We're done with the idea of the lone genius or the idea of the ivory tower. And if you were hoping to be that, I'm sorry, but it's not really relevant anymore. This is where all the work is being done now. But by working with open source, you're already participating in this free software movement. It's a very huge world. Can't wait to see what you'll do with it. So go forth and make awesome things. Thank you.
Well, thank you very much, Justin. I don't know if anyone has any questions for you.
Oh, sure.
Otherwise, I think you're around here.
Not really a technical talk, so.
I know, but there's.
Ask me anything, sure. With OpenGL, you said? Yeah. I agree. Well, they're strip mining it. We'll see if it works. I tend to think with this explosion that we're seeing now in AR and VR, that might be true for a little while, but it's not going to last. I mean, you can't sustain that. So, but you can see it, though. I mean, I'm glad that you brought that up because I hope you have an understanding that there are threats to this openness now. And the companies like Apple, companies like Google, companies like Amazon are actually making it more difficult for some of these communities to proliferate. About what Amazon's doing around like
open source projects adding anti-Amazon clauses to their licenses.
Yeah, so you're talking about like the Cloud Commons licensing that was proposed by Redis pretty recently and stuff. I mean, I can't say that Amazon has given back as much as it's taken from communities. I think there are other companies who do a great job. Enterprise DB is one of my favorite companies. That's the commercial arm of Postgres. Excellent people at that company, and they do give a ton back to the community. So there are people who are getting this right, and I think really turning this into something that's non-zero sum. I don't think Amazon's one of them.
Yeah, but what about those licenses themselves? I mean, they are somewhat kind of limiting the freedom of the licenses.
Only as deployed on a cloud substrate, I would say. If you wanted to build your own private cloud, you're free to do any of that. And you're always free. You don't have to use the prepackaged services from Amazon. You can just spin up an AMI, just a CentOS AMI, and install your own software, you know?
Okay, thank you very much, Justin.